I feel like I cut the lesson short in terms of what I wanted to add to this lesson because there's definitely some substitution stuff that I would have liked to add here. So question 8 is similar to question 7, in which if we try to do a straight integration by parts at this point, we're going to run into some trouble, some issues, right? But we can make kind of a nice substitution here. If I say a is equal to the square root of x, then the derivative of a would be 1 over 2 square root of x dx, which means that we would get dx is equal to 2 root x dA. We could rewrite this integral now as that equals dx. So this means that we can rewrite this integral as 2 radical x cosine of a dA. I'm going to pull this 2 out front. But notice that, well, a is equal to the square root of x. So I'm going to replace this with just a. So this is like taking the antiderivative of 2a cosine of a dA. And this is now something that we can do a little bit of integration by parts for. We might have actually did this one. I don't know. Did we do like an x cosine of x? I feel like I've done it at some point in my life. Oh, we did x cubed. All right, so if we said let u equal a, this means that dv, so v, is the cosine of a dA. The antiderivative of the cosine of a would be negative sine of a. The derivative of a will just be 1 dA. So our integration by parts is going to be 2 times u times v, negative a sine of a minus the antiderivative of v du. So we have minus, so this negative is going to turn this into a positive sine of a dA. All right, so the antiderivative of the sine of a is just negative cosine of a plus a constant. We have a negative a sine of a all times 2. We can actually put this in here. And then let's just plug back in what our a was. All right, so we're going to have 2 times negative radical x sine of radical x minus the cosine of radical x plus a constant. Again, not something you will be tested on.